All right, we're going to take a look at 2.4, really just continuing to solve systems of equations using substitution. Have a couple just multi-step equations here that we will practice, and then we'll do a couple solving by graphing to keep that fresh, and then take a look at solving systems with substitution. So when we're working with multiple step inequality, or equations, we are going to take our distribution, whatever's distributing, and we do that first. So we distribute negative 5 times negative 3 is positive 15. Negative 5 times positive 3r is negative 15r. Rewriting the rest of my equation. The next step is to combine any like terms. In purple, I'll highlight I have a negative 15r and a negative 4r. When I combine those, they make a negative 19r. We want to make sure that we rewrite everything. My next step is to solve the two-step equation. I'm going to get rid of the 15 first by subtracting it. Those will cancel out, and I'll rewrite negative 19r equals 72 minus 15, which is 57. My last step is to divide negative 19 to both sides. And when I calculate that, 57 divided by negative 19 will give us negative 3. In number 2, we are taking, again, our term that's distributing. We always look to distribute first, then combine like terms. So when I distribute this, I do negative 5 times 1 to get negative 5, and negative 5 times 3n to get negative 15n. I want to rewrite the rest of my equation, negative 65 and 3n. My next step is to combine like terms. I have a negative 15n and a positive 3n. When I combine those, they make a negative 12n. I rewrite my negative 5. Now I have a two-step equation. I'm going to start by adding 5 to both sides. Once I add 5 to both sides, I'll rewrite negative 12n equals negative 65 plus 5 is negative 60. My last step is to divide negative 12 to both sides. And we find that n equals positive 5. That's negative 60 divided by negative 12. Negative divided by negative is positive, and 60 divided by 12 is 5. We need to remember how to graph, so I'm going to give two different colors here. We have red up top. We're beginning at negative 1 and moving down 1 right 2. So in red, we begin at negative 1 and we move, our m equals negative 1 over 2. So I'm moving down 1 right 2. I can also count the exact opposite, up 1 and left 2. Put a line through that. In blue, my blue graph, we're going to begin at positive 1 and move down 3, right 2. 1, 2, 3, 1, 2, 2, 3, 1, 2. And then purple is where our red and blue meet, and we describe that as our x value. So 2, comma, our y value, negative 2. For number 4, same deal. I'll start by graphing my top equation. We're beginning at positive 4 and moving down 3, right 2. So we begin at positive 4 and we move down 3, right 2, down 3, right 2. line did not work out well. There we go. For my blue equation, we are beginning at -4 and moving up 5, right 2. So -4, and we count up 1, 2, 3, 4, 5, right 2. 1, 2, 3, 4, 5, right 2. We're off the graph a little bit, but that's going to help me make my line. Put a closed point. Sorry, just a regular point. And then we describe that with our x value, which is 2, comma our y value, which is 1. Okay, solving by substitution. We're going to take our y value, substitute it into the other equation. So 6x plus 3, and then instead of y, I'm replacing it with -3x minus 8, which I have in red. And then I'm writing the rest of my equation in black, equals -15. Just like we did in the warm-up, we are distributing first. 3 times -3 is -9x. 3 times -8 is -24. I'm rewriting the rest of my equation. I then combine like terms of 6x and -9x to get -3x minus 24 equals -15. And then a two-step equation, we are adding 24 to both sides so that -3x equals +9. And then we divide -3 to both sides to find that x is equal to -3. Now that we know what x is, we are going to plug it in. So y equals -3, and then I'm plugging in my x value, which I've highlighted. I did not highlight, I scribbled over, which I've highlighted in purple. So that's -3 is what I'm replacing, and then -8. -3 times -3 is 9, minus 8, which is 1. And then I describe this as an ordered pair, my x value, comma, my y value. Number 6, same idea. We are taking what y equals and substituting it in. So in this bottom equation here, we have -x minus 3 times our y value of -2x plus 11. And that equals -3. We are going to distribute -3 times -2 to get +6x, -3 times 11 to get -33. I rewrite my -x and my equals -3. I'm combining my like terms of -x and +6x. Signs are different, so I'll subtract to get 5x. Minus 33 equals -3. I am adding 33 to both sides. 5x equals +30. And then we divide 5 to both sides to find x equals 6. We plug that in. Y equals -2, and then instead of x, I'm going to write times 6 plus 11. So that means y equals -12 plus 11, which means y equals -1. So our x value, comma, our y value is our solution. All right. I just want you to see a lot of different practice of this, so I know I'm moving quickly, but the process should be very familiar to you. So I replace y with 6x minus 8. I'm going to distribute my 4. 4 times 6x is 24x. 4 times negative 8 is negative 32. I rewrite my negative 2x. I'm going to need a plus sign there. I can put my like terms together to get 22x minus 32 equals negative 10. I have a two-step equation. I'm adding 32 to both sides first, so that 22x equals 22. And then I can divide 22 to both sides to find that x is equal to 1. I can take that, plug it back in either equation, but I like to choose the one that has y solved for because it's much easier. 6 times x, which is 1, minus 8. So y equals 6 minus 8 when I did 6 times 1, which means y equals negative 2. And then we write our answers in ordered pair, x, which is 1, comma, y, which is negative 2. And finally, number 8. I'm going to take y equals negative 3x minus 6 and plug it in for y in my other equation. So negative 3x minus, and then instead of y, I'm putting negative 3x minus 6. And we are going to say equals negative 4. I distribute my negative. So in purple here, oops. In purple here, I have a negative. So negative means the opposite of. So the opposite of negative 3x is positive 3x, and the opposite of negative 6 is positive 6. I'm going to rewrite my other information. So I have a negative 3x here equals negative 4. 3x and negative 3x make 0x. Not ox, but 0x. So there are 0 x's plus 6 equals negative 4. So if there's 0 x's, it means it's not really there. So what I really have is a statement that says 6 equals negative 4. That is not true. 6 does not equal negative 4. And so what that means, if our x's disappear in our problem, we end up with no solution. If our x's disappear and we get a statement that makes sense, like 2 equals 2 or 6 equals 6, then we have all real numbers. Any number we plug in will work. But if x disappears and it's not a true statement, then we have no solution. And this on a graph would actually be parallel lines.